Okay.
This is Rajeev, and
hi.
Tina isn't here today, and he's gonna.
Right. So yeah. So there's two people teaching the course, myself and Tina Kapur. She's going to be here on Friday, and let me just start by going through with the agenda of what we're going to go through today. First, I'm going to give you some motivating examples about why we're trying to talk about or teach this course to you all. Now that you've had 10 or so months of computer science curriculum. Then I'm going to go over the outline of the course as well as our grading policy. And then I'll start into the lectures. And today we're going to start with algebra events and start on conditional probability. Let's see here. So the first, I guess actually maybe I should go back. I guess the purpose of this course is really to take, I guess before this you were basically dealing with a lot of deterministic systems. So when you came and solved the problem, you kind of felt like, well, I know all the I know exactly what's going on, and here's the solution. Except maybe when you were doing search problems where you didn't have the computational resources to search everything, or maybe like say for example in AI, where you might try some some methods for trying to search that are heuristic based that may or may not return a result quickly. And I think that what's interesting when I took this course at MIT was that for me it's actually been one of the most applicable courses I've ever taken. You know, I apply it in things like when I do my investing, when I do when I do different projects for different people. It always comes up because it's really the dealing with uncertainty is probably one of the hardest things to deal with, in the sense that you don't ever know if you're quite right or whether your algorithm is going to work, but you know that it probably will. And then in the rest, I guess now I'm going to get into some motivating examples of why studying this kind of stuff is worthwhile. So one thing I did for my PhD thesis at MIT was to work on a system that had some non-determinism in it, in that I guess, or at least it's something where there's some uncertainty, and what the idea was I've got to build a projection system that can display I guess a single picture, but the point is to use more than one projector. So here we've got one projector and it's projecting and it works quite well. But imagine that you have 4 projectors, and you can kind of see over here a model where there are 2 projectors connected to a computer. And in the example that I did, there are 4 projectors, and you can see how the images are overlapped. And the point is that you can actually create a very high resolution screen out of a bunch of really cheap smaller resolution screens. And the way you do that is that you basically you overlap the images and you modulate the signal going into the projectors, such that it creates a corrected image. And below what you see is an image that's actually being displayed on that same set of 4 projectors, but it's been corrected. And the point about the probability and statistics that comes in here is in the feedback system. And the thing is that you've got a camera that takes a look at what's wrong with the system. It tries to figure out where the projectors are projecting. And I guess the thing about that is that basically when you're trying to measure something like that, you've got an analog to digital converter, and a signal's coming in from the camera, and maybe the signal's like this or something like that. And what ends up happening is that you in discretizing it, in the ideal case you would end up just discretizing it and getting a perfect or not a perfect, but a very good sample set. But in reality what happens is there's noise that's introduced. So actually this signal kind of looks like this, and the trick is to try to recover it based on this noisy signal, so that from the noisy signal that's sampled you actually get the correct signal back. And the point is that in this system I had to do some modeling that required me to go back to this kind of probability and statistics thing, this probability and statistics stuff to come up with what the models are. And a lot of times you see this kind of stuff happening in machine vision, and that's an example of machine vision. Another example which is actually something you guys are going to work on a problem set, is something that that Tina is an expert at, which is image segmentation based on, here's a bunch of data, MRI data. Can you tell what the gray matter is in the image? And furthermore, can you tell what might be cancerous based on the input that's based on what the image data looks like? You might look at a pixel, look at the surrounding pixel data, and based on some model of what gray matter is, or what a cancerous cell might look like in a bunch of MRI data, you can segment this. You can segment the image and say this data indicates indicates that at this particular point, it is likely that that particular pixel, which is located somewhere in someone's, it's a representation of something in someone's head, is actually cancerous. So when you're actually doing surgery, and that's kind of something that Tina worked on, you can try to make it easier for the brain surgeon to try to make sure that he's getting out all the cancerous cells by creating a tool that lets him see, at least at some level, where you think the cancerous cells are. So then another example that in my real life that came up where I had to use this stuff was, I was asked a question about 2 years ago, this system that you've built, how do we know that it's scalable and robust? I built a system that I could show them that, with 1,000 users it worked well, and with 10,000 users it worked well. But how did they know that it would work well for 20 million users? And what I had to do was I had to come out and say, well, here's some modeling of, modeling based on Poisson processes and assumptions that will allow you to, decide how many servers to buy. And I know that you had a systems course. And these are all things that come up. And there's some nice courses that are taught at MIT about queuing theory that all sort of are based on the foundations of probabilistic systems that let you start thinking about these issues. And then just this weekend, actually, I came across something that I'm looking at investing in, and that's a company that does it basically in the power industry. They basically have, I guess in steam plant, or sorry, in coal plants, they have, they're I guess they're burning the coal, and there are these big steam pipes that are under really high pressure, and if those things burst, then there's millions of dollars of damage. And what's worse is that if you have a power plant and it goes down, then for every hour that it's down, you're losing a lot of money. And so here's an example where someone has come up with some methodologies for non-destructively measuring the acoustic emissions from several points along the pipe, and then they can determine, we think that there's a crack at this particular location, and given that there's a crack at this particular location, how long do we think that the pipe will last before you have to address that problem? And even there are examples where it may not be just it's knowing that there's a problem and knowing how long you have to fix it. So maybe you can schedule a shutdown and avoid bursting the pipe, or try to schedule shutdowns to deal with 10 different items that need to be done rather than one, so that you can save money. So let me go and jump into how the course is going to sort of work. We're going to talk today about algebra of events, conditional probability. Then we're going to move into Bayes' theorem after a little bit more conditional probability. Then on Thursday we're going to talk start to talk about random variables. On Friday, Tina is going to start talking about Gaussian random variables, and then we'll move into maximum likelihood estimation. And then Tuesday, which is your last class, we'll work on maximum likelihood estimation-based segmentation. And I wouldn't look at this course as it's sort of like a taste of all the different things. We're not going to go extremely in depth and prove a lot of things. We're just going to try to be very practical about showing you things that you should know, and that are very practical to use. Then on Wednesday there's an exam, and we'll talk about the exam results, and then hopefully Ravi will come in. One thing with Ravi is that he has a baby on the way, and the pregnant, I guess it's scheduled for the 14th, but somehow he agreed that he'd come in. So I can't guarantee that he won't come in, but if he doesn't come in, I'll come up with something else. I'll take